So now that you've read this portion on bivariate statistics, hopefully, and learned about scatterplots and the relationship between a pair of variables, as well as slope that represents the line of best fit or the relationship between these two variables, let's go ahead and practice making one of these charts in Excel. So download this data right here, Bike Buyers formatted data, very similar to the data we used above, and we'll use this to practice our line of best fit. So here in Excel, I'm going to reopen it. Yep. Here we have 3 tabs. This original tab is like the data you used earlier to make the box and whisker plots if you followed that tutorial. Each row represents a person who came into our bike store and either did or did not purchase a bike, as well as a set of demographic information about those customers that we likely collected from a survey in the store or hired a firm to find out information about them. Anyway, let's now create some scatter plots. To do that, the data has to be in numeric format. So male, female, married, single, education, these things won't work. So what I've done is created another tab here called numeric, a worksheet called numeric, where I've converted several of these variables to number form. So those variables that have only two values, like gender and marital status, we can easily convert those to just a 0 or a 1. So there's no order to these variables. We can't say that male or female or married versus single are higher or lower than the other. We simply have to know that in this case, 1 represents married, 0 represents single, and looks like 1 represents female, 0 represents male. Anyhow, let's go ahead and create or insert a scatter plot. Let's pick 2 variables. How about number of children and, notice also with education. Previously, education was represented by bachelor's, graduate degree, high school, partial college. Since there's 5 values, I can't necessarily turn that into the numbers 1, 2, 3, 4, 5, unless there's actually an order to these variables. In this case, there is. Partial high school is the lowest. Therefore, we represent partial high school with the number 1 over here. Let's sort this. Sort this one. You'll notice here, high school is the second highest education value, so it's 2. Partial college is more than high school, therefore it's 3. Bachelor's is 4. So there is some. This is not a perfectly valid way to represent education, because the difference between a 4 and a 5, meaning bachelor's and graduate, isn't necessarily the same as the difference between partial college and bachelor's, 3 and 4. However, by using these codes, we are implying that the difference between each level of education is exactly the same, an increment of 1. So it's a way to get around having categorical data. However, it's not a perfect representation. Anyhow, let's go ahead and make our scatter plots. Okay, which variables should we do this on? Let's pick something continuous as well as something categorical. Or you know what we could do? Let's do age and income. Those are both very continuous variables. So I'm going to hold down Control-Shift, select all of income. Also, I'm going to select all of age. On this one, I can't Control-Shift down since they're not right next to each other. So those 2 variables selected by holding down Control. Let's go to Insert. On Scatterplot, I'm going to choose this option, and there are a few options here. I'm going to start with just this very first one and let it insert. So we have categories. Well, I shouldn't say categories, different levels of income that have been rounded to the nearest 10,000. That's why they appear in chunks like this, because it's not a perfectly smooth values for income. Age up here on the y-axis. What we see here is a very soft trend going up. What I want to do here is add an element to this chart, trend line. So this is our line of best fit. So this is the line that has the, if you were to take each and every single dot and calculate the difference between the dot and the line, take the absolute value of all those differences to account for these that are negative below the line and add them up, this is the line that has the smallest sum of squared residuals, we call it. So this is our trend line that shows that general form of y equals mx plus b. So m, meaning the slope, would be roughly, it looks like, at about 40 and 0, this line intersected here, it would intersect 50 out here at about 1600. So it goes up 10 and over 1600. So I would call that the slope m would be 1 over 16. So y equals 1 over 16x plus b, I would call about 40 if I'm just guesstimating where that trend line is going to cross the x line. So that's how you make scatter plots and trend lines in Excel.